So this video is going to be mostly about some modifications that I've done to my Precision Matthews 1440 BV lathe. Most of this is going to be about the coolant system, a bunch of changes that I've made regarding the system itself and also in use of it. There's also a tool that I'm going to demonstrate towards the end of the video that I made specific for doing small work. Actually, it will be in my next video, which will be Milton Taper 6 to ER32 collet adapter. So one of the first things that I've added on here, because I do use coolant on this, certain operations, and some of it is large diameter disc that when I'm working on. So I put this splash shield up here because it can get quite messy. When I first got the lathe, I started doing it. It does spray over the backboard that it originally came here, the steel one, and it definitely sprays to the front of the machine. So I raised this up. It's about another foot higher. I just used angle iron, and this is it's not regular plexi. It's like a flexible plastic that's got some thickness to it, and it cleans off easy. It's quite durable. It's impact resistant. So that's just bolted in there, and I made it so it goes over the lip of the back, so anything that runs down will drip into the backsplash instead of going over the wrong side. And then I made this piece back here. Let me see if we can turn a little. And this catches the spray that comes towards the front, and most of that, if I'm working with a disc type operation, it's pretty confined to a narrow field. And even if I'm doing like a rod that I'm machining down, I can move this along. And all this does is clip over the edge. Let's see, let me move down a little. It clips over the edge here. If you see, it's just a single post on the bottom to counterbalance it, and on the bottom it's just basically a U-shape that catches this lip. And again, it's all made out of angle iron. It took a little measurement to put it together and weld it, but it's really not anything that complicated. And the same plastic is there, only instead of bolting in this, I used silicone sealant, just put a bead down and then laid the glass in and pressed it in. And this little curve here is shallow enough that the plastic just bent in. I put a weight in there until to hold it down until the silicone hardened, and then it held it fine. So I can position this anywhere I need it, and it's spaced enough that I can get in here and I can still move to get all my positions. I can work everything I need to. It is a little bit of a reach, you know, not bad, but it does get in the way enough that, you know, if you don't need it, you don't want it there all the time. But if you've got splashing going on, it's definitely worth having it on. Instead of having all your coolant spray out, gets everything near you all soaked, and plus you lose your coolant that way. So that's those two additions. So next I'm going to show a little bit on the coolant tank and coolant pump section of the lathe. I've got one modification I've done and several that I'm working on. So I'll show you what I've done and a little bit of what I have in progress. Well, first of all, the door on here, they really should have set this up with a hinge on here so you could just open it or latch. All they did was just drill tap some holes and screw it on. To put a hinge on it now, the way it's set up, it would get pretty bulky. I don't think I'm going to go that route. But what I'll probably do is I'm just going to take the existing holes and then mill out some drop eyes under here, you know, where you got the little slit down and then a bigger hole at the bottom that'll fit over the screw. So you can just kind of lift it on and drop it down, and then I'll put a nice handle in the middle here somewhere so you can lift it up nice and easy and pull it out of the way. And then, when you're all done with servicing, you just set it back on there. And you don't really need to tighten the screws, as long as they're just enough to keep it from rattling. So that's one little change I want to make on there. Inside, the way they originally set this up, it just had this spout that comes down and drops into the basin. Unfortunately, it tends to splatter all over the place, which first of all, it drips on the floor, and it promotes rust inside the cavity in here. So I really didn't like the way that was set up. It really should go straight into the basin. So this is just real simple on here. This is just sump pump exit hose, and I just cut a small section of it, just sized it out so it gets a little bend, and that just slides right up in there. You can get it in the corner, but not all the way tight, just a little room so it can flow. And that eliminates pretty much all the splashing issues. I've had this on for quite a while, and it's worked fine. So the other issue I've had, though, I've run this last year. I haven't filled it yet this year because it gets real cold here in the winter. I didn't want to have it freeze. The coolant, when it mixes with the whey oil, at least with the solution that I use, it tends to congeal after a month or so. I know a lot of guys just change it out sooner than that, but for the periodic use that I do, it tends to stay in a little longer. And what I had is towards the end of the season, the congealing, I didn't even realize it at first, but it started plugging up the pump. And when I finally saw what was going on, it was quite a mess in there. So what I'm going to do now, and I got a start on this, I've printed up a screen on my 3D printer. I've got to make a correction. I made a mistake on this. It's a little too tall. But this will fit inside here, and it's in two halves because my printer is just not big enough to do the whole width of it. So I've got a dovetail seam in here, and there'll be two halves to this. And it'll fit into the lips in here and make a nice tight fit between the point where it enters and then the side where the pump is. And this should effectively screen out all the congealed stuff and let the water flow through. And if it gets bad enough, it's easy enough just to wipe this off and get the congealed stuff out instead of plugging the pump. Any little bit that gets behind is small enough. It'll go right through the pump, circulate back, and end up on the right side of the screen. I don't know if we could see this in the camera. Get a close-up of it. And I'm going to put this up on Thingverse. I'll put a link to it under the video. I've got a number of other things on Thingverse as well. This is a work in progress. Like I said, I've made an adjustment. I've got one printing right now, which I've got to wait for it to finish before I can try it. And the other thing to take note is this is specifically for the Precision Matthews VV1440. There's a possibility it may fit other machines. I don't know. But if you have one of these, I'll make it freely available for anyone to download. I'll also probably put my CAD files up there so that if anyone wants to do modifications to it to make it fit their machine, they'll be welcome to do that. So I got the screens finished last night. This one I've already had in the tank just to check fit. This one hasn't been in yet. You see they got a little dovetail here. See if we can get that to show in the light. That's the mating side. So they just fit right together and get a little seal in between where the dovetail is, and this should fit right inside the tank. You know, come right back with it. Okay, so I got it pressed into the tank now, and there's a little, it's hard to see, but there's a little curved lip right on the edge of these on both sides that runs all the way down the edge of the wall and makes a nice tight seal along there. And I printed these out of Pt1, which is a somewhat flexible, it's the same material that soda bottles are made out of. It's also high temperature resistant, which isn't an issue in here. Certain applications it is. It prints really nice, you get really nice finishes with it. It's a very strong material. It's usually my go-to plastic for printing, though certain applications call for other plastics. But this seems to fit very well, at least as good as I expected, if not better. And I will definitely be posting this up on Thingverse now that I see how it fits. Also, something I wanted to show on the back of the lathe here. This is where the swarf tray drips in and runs into the tank basin. It's got a little catch tray. It's at a slight angle, if you can see that. But if you notice down here, what I've done, I have a couple of magnets on here. And what this does is, especially if you're doing cast iron, you get a lot of filings. Fine filings, which are problematic. So this helps collect them, and all I do is stick it on the bottom, directly under where it drips into this, the little catch pan here. And it just makes these are just old speaker magnets, and it creates a magnetic field that's circular up there. And it just, as it drips through into the catch pan, it just catches all the iron filings and holds them right there. The water runs through. And I'll take a look at that from the other side here in just a second. It's a good idea to make some kind of mark around here so it's easy to put the magnet back on when you clean it. To clean it, I pull the magnet off the bottom, set it aside, and then you can just take a paper towel from the other side and clean it out. And then put your magnet back on there, and you don't have trouble with the filing sticking to the magnet itself. It's best to have the magnet so you can remove it away from the filings. And it definitely helps to keep all the filings out of the circulation. So this video is actually going to be for two series that I'm working on. One is going to be the arbor that I'm making for the slitting saw for my mill, which I made this part the other day, which is the main arbor. Today I'm going to make the cap that goes on here that holds the slitting saw down. Show roughly how that's going to go. So that'll be the slitting saw there, and there'll be a cap that bolts down with this Allen bolt. But the other part is with the lathe mods that I did to this lathe, and I'm going to show the last part of the cooling modifications that I've done. Namely, this hose here, the valve I've added, and this part up here, which is it's an auxiliary coolant nozzle. And it bolts right onto an Allura style tool holder. I can dig one out here. So not the post itself, but what it does, it sets over the clamping screws, and then you can just, if you can see it here, there's a little silver nut, you just put one on each end just to hold it down. You can even use it without it, but it does tend to tilt and go out of adjustment, so it's nice to strap it down with the two nuts. The nice thing with this type of setup is that when the tool moves, along the lengthwise axis, it moves with it, and it's always aimed directly where you want it. So you don't have to worry about your nozzle going out of adjustment, that the flow is not in the right spot as you move along the work. This is my own creation. I have this posted up on Thingverse. It's there right now. I'll probably add this video up there as well so people there can see the video. Here are some still shots for a better view. And some video of the tool in use.